Okay, so where we left off yesterday is we basically got our air traffic control game to be able to draw itself to the screen. We have an update process going on where any changes to the model get updated immediately to the screen. But as yet, we don't have any animation, true animation going on. And that's because we haven't told the planes how to change their position based on their velocity. So I think that's the next task we have to do. You may remember I saved down the Dolphin image, so let's restart now. And one of the great things about Smalltalk is that when you save the image and you restart, you get back to exactly the same situation you were in before. And so we still have our instance of the game running in this ATC presenter, and it's updating in the background. So let's go and add some update processing to get the movement onto the screen. If we go to ATC presenter, now in order to accurately time the updates, I think what we need to do is we need to keep a recording of the last time the update was done, so we can tell the exact number of milliseconds between each frame. So let's create an instance variable, call it last update time. Okay, we'll compile that in. Okay, and we'll set that in two places. One, when we start the update process, we will initialize that to the current time as milliseconds. So we're storing milliseconds in our last update time instance variable. And then we'll also use that in the update game method. So in the update game method, after we've done any update processing, we'll record the current last update time. Okay. Now, in order to initialize that that variable inside this process, we would have to restart the update process normally. But since we've actually gone through a couple of cycles now, we'll have that already updated. If I take a look with the debugger, or some with the inspector, and I click on here and bring up an inspector, you'll see that I already have a last update time set in milliseconds, so that's fine. Okay, now as part of the update game processing, we're going to ask each plane to update its position for a particular time difference, and we're also going to pass over the model, and the reason we do that will become plain a bit later on. So let's go through, let's enumerate through all our planes. Okay. And for each one, we're going to send each update for a particular time interval, and that time interval is going to be the current time minus the last time. Let's actually take this and put it inside a temporary. Okay. And so we're going to update interval for the current time minus the last update time. So that's going to be the number of milliseconds since we last updated ourselves. And we're going to just pass over, as I said, our model. Okay, let's compile that, and we should expect an error here or a walkback here, because we haven't yet written the update for time interval in model method. Okay, and our familiar walkback pops up, so let's go and implement that method. Let's change the name of this parameter to time interval. Okay, and now what we want to do here, basically we want to get hold of the current velocity, and we want to add some scaled version of that based on the time interval to the current position and reset it back into the model's new position. So let's create a hang on, I've just got a problem with the keyboard here. Okay. So the let's create the new position. And the new position is going to be equal to the old position plus the velocity times the time interval times some sort of scale factor. I'm not really sure what to choose here, but let's just choose some fraction, say, and we can see if that makes it move at a reasonable speed. Okay, and then we can, once we've got calculated that, we can set that into the position of our okay. Now let's just move the debugger over here so we get some view of what's actually happening when we let this run. I'm going to compile that now and run it, and that instantly took our presenter off the screen. So let's go and change that scale factor slightly. Excuse me. So in order to reset that, let's bring up an inspector and find our plane. Okay, and we can see it's got a very large position at the moment. Let's change the velocity now to some low value, 5 at 5, and let's change our position to point 0. Okay, well that's not too bad now. We've actually got that back on the screen with more reasonable velocity. Excuse me. So now you can see that we have our plane object moving around on the screen, and in fact we can go in here with our inspector and we can change the velocity directly. So if I actually increase the x velocity, you can see we start to move across the screen. We've got no flight level at the moment, so let's put that up at flight level 3,500, or sorry, height 3,500, which will give us flight level 35. But for some reason that hasn't done that. Okay. Let's stop our plane. Oops, I've got a division by 0. Let's just go and check that. See what's happening in here. Let's go down. Seems to be in our draw on method. Oh, I can see what's happened here. We've given it a 0 velocity, and then we've attempted to divide by that here. So basically what we need to do is put a guard clause around this and say that if the velocity is greater than 0, then we will perform that operation. Let that run. Okay, let's just try bringing this back with a negative velocity. It's still working, that's great. Okay, so yes, our problem was, why are we not getting a flight level being displayed? Let's check that. That's working now. Okay, that's great. So we've got one plane on the screen and we can move it around. Now, why don't we try introducing another plane into the mix here? So I'm going to dismiss this this inspector just for the time being. And another thing we might want to do is let's write a method of the plane where we can actually stop it in midair, although it's a little bit unrealistic since the plane would fall out of the sky if it's not moving. But let's write a stop method. If we execute that, once again, we can get coded in the debugger, and we can implement it as self velocity is 0.3d0. If we got that right, we should see our plane has stopped. So while it's stopped, let's go and add another plane to the mix here. I'll rearrange this. Let's call it BA196, and let's give it a starting velocity of 0 as well, so we actually don't have anything moving around. So we'll execute that, and we'll now add that into the game. And there we go. So we've now got two planes on the screen. One thing it might be worthwhile doing is changing the flight level at some point. But we'll do that in a minute. Now I'm going to show you something now, which is actually quite key to the way you can manipulate objects in Dolphin Smalltalk, visual objects, is using the visual object finder. We've already seen that if we go up here and choose the visual object finder, then I can move the cursor to a particular window and click on any particular visual object. If I click on this ATC presenter, I will get an inspector that shows as the ATC presenter. Now, it seems to me that it would actually be very convenient if we could go and click on any of these objects in the scene and get an inspector directly on that object. And in fact, there is a way to do that. What we need to do is, inside our view, we need to implement a new method called visual object at point, and let's go and do that now. So I'm going to go to the ATC view, and I'm going to create a new method called visual object at point, and it's past a point. And what we want to do is we want to go through and detect to see if that point is inside any of the boxes of our planes. So we will answer self model detect each, and we're going to test to see if each box contains that point that we've been passed. Okay, and if it does, then we'll answer that particular object. If no points are contained, then we want to answer the what would have been passed back by the superclass implementation. So we'll just forward this onto our superclass. Okay, let's compile that. Now let's go and see if we can pick up the visual object finder, and let's drag this over. Now, okay, so that's not quite what we wanted. Let me just dismiss that. Of course, what I should have done is asked to enumerate through the planes, not the model itself. Let's compile that. Try again. And now let's see what happens if we click on this particular plane here. Fantastic. We've got now an inspector which is looking just at that one plane. So for example, I can now modify the velocity here to make it move vertically downwards. As soon as I compile that, well, accept that rather, and we're going down. Let's make it a little bit faster. Okay, and indeed I can talk to this object directly. I can type in this with the object selected. I can use self here to talk to the object and say, for example, stop. Okay, so this is a great feature of Dolphin, where you can interact with your applications visually. And so I could have one, excuse me, I could have one inspector talking to this plane and one inspector talking to this plane. Okay. As it happens for this demonstration, I'm going to use a single inspector, which is actually looking at the whole view. This is just purely to save screen space, since the double inspector idea is normally more convenient. So I'm going to drill down into our model, and I'm going to, in fact, let's go on the instance side. I'm going to drill down into our model, and I'm going to look at the two planes here. Okay, so I have this plane and this plane, and I can now talk to these directly. So if I go to plane BA188, I can make that move upwards if I like by doing a minus velocity. Okay. Stop that. Okay, so another thing we might want to do is we might want to detect to see if a collision is likely. A good way to do this would be to change the colour of the plane objects based on their distance apart. So if I go now to ATC plane, first of all I'm going to actually put a colour instance variable in here so we can change the colour of our planes. And what I'm going to do is I'm going to lazily initialize that inside our colour method. So if it's nil, then I'm going to set it to be our default colour. Which is a method that we will complete in a moment. Sorry, excuse me. Okay, and let's implement that and answer colour green, dark green. Okay, that's great. So we've now got our colour method working. We can just make that default colour method private. So now inside our update processing method, let's also call a collision detection method. So I'm going to pass, once again, I'm going to pass the model over here because I'm going to need to be able to access the other planes in the model, and that's why I passed the model over to this method in the first place. Okay, so we're going to implement that and build that in the debugger. Okay, so the first thing to do would be to detect what the closest other plane is in the scene. So first of all, let's create a temporary variable called min distance. Okay, and let's also have an instance variable planes to test. Obviously, we don't want to go when we're going through all the planes in the scene. We don't want to check to see if our plane is over the top of itself. So let's reject it from the testing. So we'll say planes to test is equal to an ATC model planes copy without self. And another good thing about coding in the debugger is we have all the context available, so we can actually, if we want to, we can actually execute that line just in line here. This is quite an interesting thing to do. So let's just see what happens if we do that. We get an ordered collection with ATC plane BA196. We are BA188, so we've seen that actually works. That's a useful little thing you can do because we're doing the coding inside the debugger. So notice I'm not drinking coffee like I said I would be, because this is actually now the next day. Okay, so going through our planes to test, let's try and find out what the minimum distance is. And we can use one of those nice Smalltalk methods called inject. And we'll inject a large number into here and then whittle it down to be the minimum distance. So we'll get a large number, we can use float fmax, and we'll inject that into okay, and here we can find the distance between the two planes by taking the R value of the difference of their positions. Position minus each position. Okay, and take the R value of that. And then, as the result of this block, we will want to return the minimum value of current min and this distance. So let's just do that. So we answer current min distance. Okay, and once again we can just test that's working. Okay, and that's given us our current distance between the two planes. Okay, so now we can test to see if these two things are within some sort of threshold and change the colour to be, say, red as a awarded colour. So what we can do is if the if the min distance is greater than say 200, we can early out, we can set the colour and early out. We haven't actually implemented self colour yet, but we'll do that in a second. Okay, and we'll answer that from this method so we come straight out. If it's less than 200 but greater than 100, greater than, well, let's call it greater than 50, say, which is the collision distance, then we can change the colour. And if it's actually well, we could do some destroy processing here. We won't do that right now. But if it was less than, say, 50, we could actually do we could destroy the plane. So we could say here an ATC model destroy plane itself. Okay, let's let's parameterize these. Let's move these out into methods. So this is going to be self warning distance, collision warning distance. Okay, and this can be actual collision distance. Okay, and now let's run that. Accept it. Sorry, it should be self. Now we need to run. Okay, we don't have collision warning distance defined yet, so let's implement that as 200, say. And run it. We don't have collision distance defined yet, so let's implement that as 50. We don't have collision color defined yet. Let's call that color red. Run that. And we haven't defined our color method yet, so let's define that and run it again. And now we see that because the distance between these two planes was less than 200, we've actually got them to be red already. So let's now go into our inspector where we're inspecting those two planes, and let's cause them to move apart. So I'm going to move BA188 along the positive x-axis. And we should see when we get past a certain distance, so I hope you'll see this, we've gone green. That's fantastic. Let's bring this back into the frame again. Sorry, this one. Okay, let's just stop it. Okay, I'm back in line again. Now, what I'll do is, I think what we'll do is we'll position one down the bottom, and then see if we can go for a real collision. So let's position BA196 towards the top. Okay, and let's fire the two planes together. Let's give this one a velocity of 100 and 100. Oops, so that's the wrong plane. And give this one 50. Okay, let's see what happens. So we've got a collision warning. And now when they get close enough together, we see the ATC model does not understand destroy plane, so let's go and do that. Let's implement that method inside ATC model. We're trying to destroy BA188, and so what we'll do is we'll do self planes remove. Obviously you would do some sort of sound effect here or whatever, if this was a true game. Let that run, and we see that that plane disappeared. This one actually didn't get destroyed because we need to put another bit of code in to also destroy the plane that it crashed into as well. But anyway, I think you can see now that we've got quite a long way with this, and I think it might be time to take a break before continuing on and tidying it up and putting it inside a different set of windows. Okay.